Hi everyone. Tonight we're going to be talking about using properties of exponents. So we have 7 rules for simplifying exponential expressions. And the first one, let me get the pen there, is any number with base a, an exponent m, multiplied by another value with base a, an exponent n. When multiplying these two values together, we can rewrite it with one base and add the two exponent values together. So I'm going to give you an example. If I have x to the 4th times x to the 6th, I know just applying this rule, I can add these two together and our answer should be x to the 10th. But I'm going to show you why this works. So x to the 4th is really like x times x times x times x, and x to the 6th is really 1, 2, 3, 4, 5, 6 x's. So we can write it out in terms of x. And then when I just count how many x's I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that does equal x to the 10th. So you don't have to write out each of your terms before you add them. I just wanted to show you how it works. So you can just apply this rule. When you're multiplying two values with the same base, you can add their exponents. Alright, the second rule, we have a to the m power, and if we raise that whole thing to the nth power, we get a to the m times n. So now this is what we call power to another power. We multiply the exponents. So for example, if I have a to the 4th and that whole quantity squared, in order to simplify this, I would just need to multiply these exponents in order to, when I am applying rule number 2. So that would be a to the 8th, because 4 times 2 is 8. Alright, rule number 3. So if I have ab to the m power, I can rewrite this as a to the m times b to the m power. So for example, if you had y z to the 3rd power, you would get y to the 3rd times z to the 3rd. You just raise everything inside these parentheses to that power. Alright, number 4. This says that a to the 0 power equals 1. Well, it's true that any number to the 0 power is just 1. So if you had x to the 0, your answer would be 1. If you had 9 to the 0, it would be 1. So anytime you have a value taken to the 0 power, the answer is 1. Alright, I'm going to continue my rules over here. Rule number 5 is a to the negative m. So if you have something raised to a negative exponent, you can make this into a fraction, right? It would be a to the negative m over 1. Well, when you take the reciprocal of that, the exponent becomes positive. So, for example, if you had x to the negative 4, in order to make this exponent positive, which we do when we're simplifying exponents, it becomes x to the 4th power in the denominator of that fraction. Alright, rule number 6. I'm just going to put this ex there so we know that it's an example. I have that a to the m power over a to the n power is a to the m minus n power. So remember that this line means divide. So anytime you're dividing two values with the same base, you can subtract their exponents. So again, I'm going to show you why this one works. So if I had x to the 6th over x squared, I really have x times x times x times x times x times x over x times x. Well, look what happens. X divided by x cancels, and x divided by x cancels. And how many do we have left? Well, the answer is x to the 4th. So all you really need to do, you don't have to rewrite all of these x's, but you can notice that when you divide both of these two numbers or values since they have the same base, I can subtract their exponents. So 6 minus 2 is 4. And then the last one, which is similar to rule number 3, if you have a fraction, a over b, to the m power, you can take each part of the fraction and raise it to that power. So I have a to the m power over b to the m power. So, for example, if I had x over y to the third power, I would have x to the third over y to the third. So these are our rules, and if I went too quick for you or you didn't get everything written down, make sure you pause and rewind to make sure you have all of these rules so you can use them in class tomorrow. So I'm going to go through a couple examples, as many as I can in the next couple minutes. So the examples I gave you were basic to the rules that I gave you. So it was just one rule per problem. But a lot of these simplifying exponents problems are going to have a lot of rules mixed into one. So here's what I mean by that. So example 1. I want you to simplify 2m to the 4th, b to the 4th, m to the negative 2 power, times 3b to the 6th. So I am multiplying each of these terms together. So we have to look back at our rules. Well, the first thing I want to do is multiply these two numbers. So since I'm multiplying everything, I know that 3 times 2 is 6. And it can get confusing when you're mixing numbers and exponents. So you just have to be careful you're doing the correct operation on your numbers. So remember back to rule 1. Anytime you multiply values with the same base, you can add their exponents. So let's do that. If I'm multiplying m to the 4th and m to the negative 2, I can add their exponents. So 4 plus negative 2 is just 2. And then I can move to my b's. I have b to the 4th and b to the 6th. Well, b, since they have the same base, I can add their exponents. 4 plus 6 is 10. So my answer is 6m squared b to the 10th. All right, let's do another one. Example 2. If I have 5w to the 6th, all raised to the 3rd power, remember back to rule number 2. Anything inside parentheses raised to a power, you can multiply exponents. So the first thing we need to do, okay, so let me rewind for just 1 second. It combines rule number 2 and rule number 3. So I have two different values inside the parentheses in the given problem, and I'm raising them to a power. So I can rewrite this as 5 to the 3rd power and w to the 6th power raised to the 3rd power. So this is, you could see it a little bit better. That was rule number 3. So now if I apply rule number 2, a power to another power, I can simplify this even further. Well, first, 5 to the 3rd power is 125, and if you need your calculator, feel free to use it. And then I have w to the 6th raised to the 3rd. And remember, when you take a power to another power, you can multiply your exponents. So 6 times 3 is 18. So sometimes you will be combining a couple different rules all into one problem. All right. Here's example number 3. If I have 6x squared y to the 11th over 3x to the 7th y to the 3rd, I can simplify this problem. So remember that this line means to divide. This is a very common mistake, so you have to be careful. We really are dividing 6 by 3. So 6 divided by 3 is 2. And that stays in the numerator of our fraction. So then I can move to the x's. I have x squared and x to the 7th. And if we scroll back up and we look at rule number 6, when we're dividing two values, we can subtract their exponents. But I want you to be careful of something here. So you can do x to the 2 minus 7th power, but then you're going to have a negative exponent. So I want you to make a note before you start subtracting. Whichever number is bigger between the exponents, so here I have 2 and 7, and we can all decide that 7 is bigger. That means our x's are going to stay in the denominator. And I'm still going to subtract them. So 7 minus 2 is 5. We do this so we can avoid negative exponents. If you wanted to do 2 minus 7, you would just end up with a negative exponent in your numerator and then have to move it back at the end. So if you just take the time in the beginning to see which number is bigger and to tell you what whether it should stay in the numerator or the denominator, you could save yourself that step. So then I have my y's. I have y to the 11th over y to the 3rd. Well, which number is bigger? 11. So y is going to stay in the numerator, and 11 minus 3 is 8. So I'm going to write this just a little neater. So I have 2y to the 8th over x to the 5th. And that's my simplified answer. That's all I have for you tonight. Hopefully you feel good about these 3 examples. If I went quickly or you may have some questions, I recommend rewinding and rewatching me go through these 3 examples, and come prepared to ask questions in class. Look forward to simplifying exponential expressions tomorrow.